I'm Frank Partnoy, and I'm the author of Wait, the Art and Science of Delay. I'm a finance person, so one of the things I did for Wait was interview people in the financial markets, and particularly high-frequency traders. High-frequency trading is now 70% of the U.S. stock market. This is trading that occurs in just milliseconds. And I found an intriguing example that involved a company called UNX. UNX was at the bottom of the league table charts in terms of execution. Their strategy involved high-frequency trading of small-cap stocks. And their chair, Andre Parold, was the head of Harvard Business School's finance faculty at the time, a very, very smart guy. And he decided that the company needed a new CEO and needed someone who thought outside the box, who would be creative. And he hired a man called Scott Harrison, who not only had a lot of experience as a computer programmer and high-frequency trader, had built a lot of complicated algorithms. He also had been an architect at Skidmore, Owings, Merrill. He was a chef. He was a gifted carpenter. He was a Renaissance kind of guy. So he was brought in, and he reworked all of the computer algorithms, rebuilt the computers, and set them up in a small office in Burbank, California, 3,000 miles from the New York Stock Exchange, flipped the switch, and suddenly UNX went from the bottom of the league tables to the very top of the league tables. And Scott Harrison was a hero, and everyone was very, very happy. So the reason they were able to be so effective was essentially that there's a kind of war game taking place in the financial markets where this computer algorithm is fighting this computer algorithm, and they're trying to be faster, but they're also trying to be better. They're trying to trade stocks as cheaply as they can. They're also trying to take advantage of information that's available in the marketplace. So there are a bunch of different factors: how fast you are, how much information you're able to glean, and what everyone else is doing. And Scott Harrison's new model was able to outperform on all of these axes. It was able to execute trades at lower prices, and it was able to take advantage of information in the market, and it also, frankly, was able to outcompete these other computer algorithms. You can think of it as sort of almost like a sporting event where all these computers are lined up and they compete against each other, and he had built a computer that was more powerful, faster, better, and so they were able to make more money. They were able to execute stock trades at cheaper prices and outperform. That's right. And what Scott Harrison and the others at UNX decided was, okay, we've gotten this good. Our trades are taking 65 milliseconds to execute. 65 milliseconds. We're out in Burbank, California, 3,000 miles from the New York Stock Exchange. If we co-locate, if we move our computers right next to the New York Stock Exchange in Manhattan, we will shave about half of our execution time. And the reason for that is that it takes a while, even at the speed of light, for the signal to go through fiber optic wire from California to New York. It's 3,000 miles at the speed of light. It takes 30 to 35 milliseconds. And if we can shave that time off, we'll be able to execute trades in half the amount of time, 30 to 35 milliseconds instead of 65 milliseconds. So they pack up their computers from Burbank, they ship them to the New York Stock Exchange, they flip the switch again. Now their execution speed is twice as fast, and yet they move from the top of the league tables back down to the bottom of the league tables. And it's the strangest result. People in UNX can't understand it. Andre Parold and Scott Harrison, who are leading the company, who are two of the smartest people in the financial markets, are puzzled by this. They bring in their engineers to try to understand what's happened. And then Scott Harrison, the Renaissance guy, the outside-the-box thinker, says, hold on a second, why don't we try something radical? Why don't we try telling these computers to slow down, to run at the same speeds they had run effectively when it was taking them longer? Basically, what he's telling them to do is to procrastinate at the speed of light. He's telling them to go back to 65 milliseconds. So they do this. They slow down their computers, And when they slow down their computers, they go back from the bottom up to the top. And the rationale for this very strange result, that being slower is better, even in the high-speed, high-frequency trading world, is that being the first mouse can be incredibly dangerous if there's a feral cat around, that there's a first mover disadvantage. If you're the first mouse, you're eaten by the cat, and the second mouse gets the cheese, that there's a second mover advantage. And the reason for that has to do with the nature of this war game between the high-frequency algorithms, that sometimes what these high-frequency traders are doing is sort of like what a fencer is doing, faking the first move. If you respond to that first faked move, you'll react incorrectly. And so some computer algorithm might be pretending to buy in the first few milliseconds when really it wants to sell, or the opposite, or it might be implementing some strategy that suggests or might suggest to a less sophisticated algorithm that there's new information coming into the market, so everyone should buy, but actually they want to sell. And so the advantage that UNX got was taking an extra few milliseconds to step back from the fray, to let these other computers execute their potential trickery, their other strategies at very, very high speeds, and then step in at 65 milliseconds. Now, one of the really intriguing things about the high-frequency trading market is that although 65 milliseconds was the optimal strategy for a brief time for UNX in this particular market, it wasn't for long. That there's a kind of optimal amount of delay that shifts and varies over time based on who else is playing in this war game, based on what kinds of opportunities are available, based on what information is coming into the markets, and that is variable over time. And so there's evolved an industry in what is called managing latency. Latency is a kind of very high-speed delay, and it sounds crazy in the context of high-frequency trading, but it's actually quite common in all of our lives. When you ask someone via the web to work on your computer, they ping your computer and they might send a packet of data to your computer. If your computer isn't ready for it, can't operate quickly enough to process it immediately, if it arrives too soon, that's disastrous. It gets lost. So one of the things that computer hardware designers will do is build in a certain amount of delay at different times. Software as well, certain amount of delay depending on the relationship between computers. The same thing is true in telecommunications. If you're talking on the phone, the sound of your voice is being delayed. We cannot hear a delay of 150 milliseconds. So the telecommunications companies could speed up their signals. They could have the delay be only a few milliseconds, but why would they spend that money if we aren't hearing it? It's the same sort of rationale for why we wouldn't pay extra to have a package delivered overnight arrive at 8:59 a.m. versus 9 a.m. It's not worth it. Arriving at 9 a.m. is fine. And it's the same sort of idea in telecommunications and lots of technology where you're optimizing delay. You're paying for a certain amount of reduction in delay, but not the maximum amount. I think there is a link between the unhuman computer processing of information and these high-frequency decisions, in a way, that are being made by computers and human decision-making, which is operating at a much slower speed. It relates to the premortem idea in a way, because essentially what's happening is that the human high-frequency traders are trying to anticipate what might go wrong or right under different kinds of market contingencies. And they're programming the computers to respond in different ways based on what might or might not happen in the future. And that's entirely human agency writing the code that the computers then follow later on. Now, in the heat of the market, where prices are plummeting, human agency is gone. The computers are reacting as they were programmed automatically. And one of the problems in the flash crash was that the way the computers were automatically responding to this decline in prices that was triggered by Waddell and Reed's very simplistic selling algorithm. This is one money manager in the Midwest that had an algorithm that dictated a certain percentage, 9% of volume, that it would sell periodically. And one of the things that happened was that the other algorithms were programmed in a way that caused them to pull out all of their bids, the willingness to buy when there was a rapid decline in the market, essentially evaporated. Because humans had programmed the computers to do that, to pull out the liquidity, to pull out their willingness to buy in that sort of market scenario. Regulators have been puzzling through how to react to this problem. One of the things that they've done is to eliminate the ability to use what are called stub orders, which are orders for stock that you would agree to buy at a penny. And it was a way to comply with a requirement that you, as a market maker, have a two-sided market, that you'd be willing to both buy and sell stock. But some people in the market were effectively complying, but not really complying, by saying, okay, I'll buy, but I'll only buy at a penny, which is why the stocks, some of these stocks went from $40 a share instantly down to a penny a share, because only those stub orders at a penny a share were the only ones remaining in the market. Regulators have said you can't do that anymore. You can't use stub orders. But they've been puzzling through what you do when the computers, basically the bottom falls out of the market and the computers are no longer willing to step in at a certain price. And one of the things that regulators have been thinking through is both using delay, using a pause, and also using certain kind of barriers in the market, which would prevent trades from going below a certain level, say 5 or 10% below where the market was for a certain period of time.